Our second talk of the evening is presented by Sajit Gurubacharya, exploring Australia's electricity market with Databricks on GCP. So Sajit Gurubacharya is a data professional with over 7 years of experience across energy, transport, and finance. So he is currently the data lead at Bonpu Energy and has previously worked as a data and AI manager at KPMG. And he is passionate about turning data into real insights and also mentor students and early career professionals, especially international students starting out in Australia. Please welcome Sajit Gurubacharya.
All right. Good afternoon, everyone. Can everyone hear me? All right. Fantastic. And I blocked the slides a bit. All right. Cool. So yeah, it's been it's a bit late, but since it's summertime, it feels like a 5 p.m. on a winter. So hopefully you guys aren't too tired. Today we'll just go through exploring Australia's electricity market. Just a quick show of hands. Does anyone have experience in the energy sector? Or yeah, we got a few at the back, a few more that may or may not be raising their hands. Cool. All right. Before we begin, please scan it if you want to connect on LinkedIn. My name is Sajit. I currently work as a data lead for a renewable energy company called Bonpu Energy. Prior to that, I was a manager at KPMG in their data practice, and I started my career at PwC. So later, if you want any to talk about career and all that, I'm more than happy to talk to you guys. All good. Thank you. All right. Easy. Okay. Cool. So today we'll just go through energy basics. This is, I think less than 10% of the people have some energy experience. So we'll go through Energy 101 for the first 10 or so minutes, and then we'll dive into Databricks and we'll go through a demo. And we'll also have Q&A towards the end as well. Okay, let's just start with a simple thought exercise. I know we're in Australia, so we don't have blackouts, but yeah, let's imagine a life without electricity. I was originally born in Nepal, so we had like load sheddings, which was like up to 16 hours of no electricity. So that was a very different life. And compared to here, we don't even have to think about not having electricity. We're already very, reliant and resilient with energy. So it's something to be grateful for. I think without electricity, we don't have internet, we don't have the AI hype, we don't have our mobile phones, we don't have trains that run, right? So I think, yeah, and today we'll go through kind of how the grid sort of works and potentially also just how the energy is supplied to our market. So the Australian National Electricity Market is what we'll talk about today. It is called the NEM. Before the 2000s, all states had their own electricity generators, so they would have their own generators and they would supply interstate within its own state. But in 1998, Australia established the National Electricity Market, which is the entire eastern seaboard. So it connected all the grid from, I think, Port Douglas up in Queensland all the way to Port Augusta in Adelaide. So it goes all the way, and also to Tasmania through the Bass Link Strait. So it's a really, really large grid network, and you can imagine that electricity could potentially travel all the way from all these lights that we see, all this internet that we have. It could be coming in from a lot of places. It itself, it has more than 600 participants. The participants are a variety that we'll go through. So it could be like a generator, it could be a retailer that you buy electricity from. And what we see here is also the mix, right? So I think we hear a lot of news about renewables and coals and retiring coal plants. You might see, we have some energy risk in the coming future, but we'll go through a bit of that. But we can see at a high level, as of last year, we're still pretty much supported by coal, and we have wind, rooftop, solar, which is a really big component actually in Australia. We're one of the largest countries in the world to have such a high rooftop solar penetration, and it's partially due to our geography and also our love for 400-acre blocks, 400-meter square block houses. And then, of course, we have grid solar and all these renewable, and we have gas. So this will be primarily what the data will be about later in the demo. So just about the energy generation mix. So this is a high-level energy supply overview. I'm sure we have some understanding, but let's go through that very quickly. So we have generators that produce electricity. It could be your coal power plants, it could be gas, it could be your solar farms, or even your rooftop solar. And we have companies that own that, like Origin, AGL, and HydroTaz. That's a renewable dam company, and it's like a government company in Tasmania. For example, and then we have transmission lines, the companies that own the roads of the electricity network that provide electricity to hundreds of kilometers all the way to your house, essentially. So like companies like Transgrid and AusNet, and they're kind of like state owned in a way. I think it's like they don't have smaller companies; they have like larger transmission lines only organizations across the state. And then at the end, we have your retailers. So you might buy your electricity from them, like Energy Locals, Red Energy. One interesting thing is that, for example, companies like Origin, AGL, and Electricity Australia, I think they are both generators and retailers. So they're called gen-tailers. So they can generate electricity and sell them. So that really creates an interesting mix for what they can do with their setup. And you can see that generators supply electricity. And we demand electricity. So it's always a supply and demand game, which we'll go through in a bit. And whenever we have a supply and demand, we have some fluctuations. Sometimes demand might be high, sometimes supply might be high, and that often determines the price of electricity. And we can think of it as like this. Demand is the driver. So we, as consumers, we need electricity. It could be your household, it could be factories that need electricity, and then ideally a grid network's incentive or like our network's incentive is to ensure that we always get the electricity that we demand. So we do not lack electricity when we need it. So supply must always meet demand to keep the lights on. So there is no buffer, like big, large buffer yet. We'll go to batteries in a bit, but there's no buffer yet. So it's always a mix of, if there's more demand, we get more supply in. And it's always almost continuous because we have different demand times or different demands across the day, for example. So let's go through some of the questions that I have for you all. And if you have any answer, just feel free to raise your hand. Let's do the first one, which is, when do we think we have higher demand for energy? So how does demand fluctuate? Summer, yeah. So when it's hot, like now, we have more ACs on, offices more AC. That's a good one. Winter also might have more demand because of heaters. Any other ideas? Peak and off peak, right? Correct. The time of the day. So maybe at 2 a.m., no one's really running their electricity or like factories aren't running their electricity, but maybe during evenings when people come back from their homes, everyone starts turning the lights on. So there's some volatility there. There's a pattern of how demand changes within day, across days, across seasons, over years. For example, if a country has a larger population, then generally they demand more electricity, for example. Let's go to the next question, which is, when do we think we have higher supply of energy? So we're thinking about generators now. When do we think we're able to supply more electricity? Midday, because of rooftop solar, because there's the sun. Correct. And if it's a rainy day, you might not get electricity, right? So it's very fluctuating in that sense. Any other ideas in terms of supply? When can we actually change? When does the supply could the supply actually change?
You mean to say the current situation or
any just
future from nuclear?
If we switch to nuclear, so we're going, that's fair, yeah. So that's like having a new energy source completely, right? And so that also brings about the different types of generators available. So things like nuclear or even coal, they could be called baseload units that always provide electricity because you can always burn more coal, you can always have energy when you need it. But things like solar, if there's no sun, if there's no wind for wind farms, you're kind of stuck. So there's both a volume of supply question, but also a resilience question or like a guaranteed question when it comes to electricity. So just kind of things to think about, really. And when you think about the continuous flow of electricity, it's every second, yes, But from a data perspective, AMO, which is the Australian Energy Market Operator, and they kind of set the brain of data and electricity supply for us in 5-minute blocks. Previously, it was 30-minute blocks, so they would say we have this much demand and this much supply in this 30-minute block. Now the grain is 5 minutes. So every 5 minutes, we have a price for a varying price for electricity that the generators get, for example. Cool. So that was a bit, and oh yes, and then prices fluctuate quite a bit, and it is a supply and demand thing, and I think there's a lot. This is a very big topic, but at a high level, prices can fluctuate up to, I think it's 21,000 now per megawatt hour. So you can have a price spike when, for example, everyone wants it's a very hot day and everyone turns their ACs on, but there's not enough coal or solar or wind to support that. So then, because there's more demand, then the generators can charge a higher price to meet that supply, which is really like in the 20,000s. The average, let's say, it's around like less than $200 per megawatt hour every 5 minutes. So we're talking about a 100x spike. On the other side, there's also electricity that can actually fall as to a negative price. So sometimes generators bid in a negative price just to get into the market, because in terms of how the price is set at a very high level, generators have a bid stack that they say, okay, I will provide this much electricity at this much price, and the cheapest electricity gets let in. So there's an incentive for generators to be fairly, tight, or like think about how much they want to bid in at what price. But the interesting thing in the NEM is that the generator that sets the price is the generator that meets the demand. So for example, at a high level, let's say we want 1,000 megawatt hours of let's say there's that much demand. And then solar farms, let's say, fill in the first 500 megawatts hour, and they're charging only $20. But if to fill the 1,000 demand, a coal power plant comes in and they're going to charge $50 for that same energy, then both the coal and the solar farm that provided the electricity, they both get $50. So it's a very interesting mix of how it was designed and what incentives are there. But ultimately, it is to ensure that people like us, the consumers, demand is always met. Yep.
Just a quick question, like in terms of comparing coal versus solar versus other ways of having power, which one is the cheapest?
That's
Which one's the highest?
Yeah, I mean, like at a wholesale level, solar is cheaper because you don't have to burn anything; you just get free sun. But at the same time, like for example, with that setup, even if solar is cheaper,
If you were to buy, is it from the supplier?
right? Well, you can't, like, once it enters the grid, you can't pick and select electricity. But again, at a wholesale level, like solar per megawatt hour is generally cheaper, so they can generally bid in prices at a cheaper rate, which in turn means that a lot of the if solar is available, they get into the market. And coal and gas peakers that we'll talk about a bit later come in when there's actual need, and usually gas peakers. Cool. Yeah. And then it's just you can't see now, but there was like a Nano Banana sticker. So there's a few pictures here, and I'll just try to use Nano Banana Pro for all of these images and a lot of the slides. So this is I just told it to do everything. So you got your wind farmers and solar. You got some rooftop solar, coal, gas, nuclear, and yeah, just batteries. The batteries are a big investment. We'll see a lot of investment in the battery space in the next few years, 5 years, because since we're switching to renewables, batteries form a key component of stabilizing that.
This battery you mentioned, right?
Yeah.
The battery gets from somewhere, right?
Correct. Yeah.
Batteries maybe of any of the renewable or non-renewable resources.
Correct, but generally because batteries would charge during the day, they would be taking electricity when there's a lot of solar. I mean, there's a lot to it, but yes, you do need to charge to dispatch. Yes, correct. But batteries act as more of a buffer. So for example, you have sun during the day, but you don't have sun during the night. So you can theoretically just charge during the day and then release it at night. So that's kind of at a high level how we're trying to use renewables. You can't just expect sun to be on all the time, especially like on a cloudy day. Yeah. And yeah, so now we're kind of going to the data of electricity, and it's a very interesting market. Electricity, it's one of those sectors where there's a lot of data, partly because it's every 5 minutes, but you have your generators that have their SCADA data. There's a whole electricity trading market because of the different prices that we talked about. So there's a whole market to buy and sell electricity, like contracts. And then you also have the retail side where consumers buy electricity from retailers. So they have to hedge, like they sell to you at a fixed price ideally, but as we saw, the price is very volatile. So how do they ensure that they're not profitable, for example? So there's a big space with electricity data. So AMO, the company that I mentioned before, is the primary provider and the market operator, and you can get a lot of data from them. So that's what we're going to do. But for companies, there's other potential ways to get the data in. And when we think about supply, we know that, for example, demand changes. So how do we forecast demand? So that things like weather, things like seasonal patterns, all of that data comes in as well. So that's at a high level, but today we'll just kind of go through the generator side of data. Cool. Let me just quickly, yeah, that's fine. I'll go to the demo a bit. But yeah, I'll just give an overview in Databricks. A quick show of hands again. Has anyone used Databricks or a Snowflake? Snowflake, Databricks, Snowflakes, maybe a bit of SQL Server, but that's a bit different. Synapse, anyone? Or like BigQuery? BigQuery, yeah, okay, cool. All right, so Databricks is a data platform, a data and AI platform, you can call it that, but it was actually started in 2013, so it was founded by the creators of Apache Spark. It was, I think, out of a PhD project in Berkeley, in UC Berkeley, and they, I think when MapReduce and Hadoop and all that, I think they devised Spark, and Databricks was initially a platform that made it more easier to use Spark, and then since it's evolved into using like Jupyter Notebook like interfaces and a SQL editor that you see in a SQL warehouse. So it's evolved quite a bit in the past few years, and you can work on it as a data engineer, you can work on it as a data analyst, you can work on it even on machine learning. So a lot of data science people that I work with, they always come from uni. They've been using Jupyter Notebooks for all the data science workloads. So when they come to Databricks, they're familiar with that notebook-like setup. So it's always good for them to kind of get onto the data space. The other thing with Databricks is that they have a concept called Lakehouse. So for example, a SQL Server, I'm sure hopefully a lot of us has used SQL Server either at uni or somewhere, but it's like a direct warehouse, right? You like write data there, you read data there. But as we know, if you want to scale like a SQL Server warehouse, we just got to make it a lot bigger. So it has challenges. And so that's like a warehouse component. But then at the same time, we also have a lot of data that we want to consume. So we don't want to be restricted by the whole SQL Server or like a warehouse. So that's why Databricks, what they have done is they've kind of separated the compute and the storage. So your compute is stored on a like any cloud bucket, like in this case, like a Google Cloud bucket, in a form of a table format. So Delta, if you've heard of Delta or Iceberg, they're open source table formats. Essentially, what they are, they're Parquet files that have some way to be organized. So when a tool like Databricks reads the Parquet files, like these Delta tables, they can be read as a normal SQL, like a normal table. So like it's Parquet files, like a snappy Parquet file under the hood, and we will go through it a bit in the demo. And then, but when you read it for the end user, they don't even see the different complications; they just see data. So that's how like Databricks helps companies scale and have a lot of data without paying too much for it. Databricks is a platform, for example, that you can use in any cloud. So we'll be using Google Cloud today, but it acts above in the control plane, above the data plane. And so yes, some competitors there like BigQuery and so this is all Nano Banana generated, by the way. So all the text and everything is pretty good. There's no spelling errors, and even this is generated by Nano Banana. So so this is the demo that we're going to go through today. I think we're still good on time. So at the start, we're going to take data. We have a data source. We're just going to essentially scrape it off of a website that AMO provides with all these files, all these zip files or CSV files. And then what we're going to do, we're going to have like 3 different types of data sets. One is SCADA data, which means the actual generation by a DUID. A DUID is a dispatchable unit, or essentially a generator. So how much a generator like a solar farm, a coal power plant emits. or like discharges. That's SCADA data. There's a dispatch price. So this is the price per state for every 5 minutes. And then we're also going to have a separate rooftop PV data set because rooftop PV isn't part of the dispatchable grid. If I have a house, I can just put a rooftop solar panel on it, and then I can provide electricity for myself or even back to the grid. So there's a lot of new companies that are trying to optimize for this, where people can earn money just by having rooftop solar, but that's a different topic. So we'll get to those three data sources. We have a reference data set, which is essentially just the type of DUIT. So if it's a coal, like the reference data will say it's a coal, or if it's a solar farm, it'll say it's a solar farm. And then for all the orchestration and everything, we're simply going to use Databricks. So to scrape the data in, which is the ingestion piece, we're just going to use a Python script on Databricks to ingest the data, and we'll put it into folders. Then we're going to process the data. So one thing is ingestion, which means getting data from an external environment to our own environment. And the second step is to process that data. So because it's going to be CSV files, we don't want it in CSV files. There's going to be 1,000 CSV files. So we want it in a table, ideally a Delta format. And then you'll see how it's all under the Google Cloud Storage bucket. And then once the data is there, once the data is there, we can actually just do it as a SQL query, so like a select star statement. But one thing that Databricks and I think a lot of other companies have is a medallion-like architecture. Databricks calls it a medallion architecture, which just means you have a raw layer of data, then you have a more curated layer of data, which is silver, and then you have a more transformed layer of data, which is gold. So this is a pretty common terminology in the Databricks world, but a lot of different companies might have different names for it in terms of what they call these layered, curated, staged, analytical layers of data. And then finally, once the data is there in a SQL, in like the gold table, we'll just kind of use a Dash app that is on a Google App Engine to kind of to essentially dashboard and plot the data in. Okay. All right. So that was a fair bit. Okay. So let's start at the left side again. So in terms of sources. So sources, this is a website called nemweb.com.au. It's essentially an AMO website that provides files for different types of data. So for example, you can see here that we have a directory called dispatch SCADA. So we go there and you can see that, AMO provides us all these zip files. So it's like a lot of zip files. I'll zoom in because the screen's a bit small. So you can see that dispatch is roughly every 5 minutes. So even just, what time is it now? It's 7:06. And then, but the most recent data we got was at 6:02 p.m. Can anyone tell me why? Just more of a trick question, huh?
End of the day.
End of the day, correct, but not really. Any other guesses why it's an hour late? An hour late is the hint. Correct, yeah. So AMO, thank God they don't do Sydney time zones or Adelaide time zones. We all work on Brisbane time, so it's always what we call NEM time. So it's always +10. So right now it's 6:02 in Brisbane. That's why 6:02, but it is the most recent data, and it's at a 5-minute block. So I mean, if you refresh it, let's see if we get a new data set. 6:02, 6:07. So this is like a freshly landed data set, and if I open the zip file for it, it's going to be a zip file. So if I just open that. So it's like a zip file, and if I open that again, it extracts as a CSV. Hopefully it's not too small. And if I just open that just for us to view what the dispatch data is like, and I have numbers, which I don't really use, but you can see it's not the best way to view data in numbers, but I'll show you on VS Code later. But you can see that it's just formatted a bit differently. It's got a metadata column at the top. We have just the actual column names here, and then we've got all the actual data here, right? And for example, the thing I mentioned about DUIT, so like a dispatchable unit, is this. So they've all got these fancy nicknames, or maybe like a short name. So it's like Shoal One, or where's one of the big ones? Like Bayswater. Bayswater is like a coal generator up near west of Newcastle. So it's like one of the biggest generators after Eraring that provides electricity from a coal generator standpoint. So you can see that just in the past, like this 5-minute block, for example, it had an average power, like the first out of the 4 units, because they divided into 4, has provided over 658 megawatts hour of electricity, and so on and so forth. So this is just in the past 5 minutes, the average power, right? And one issue with this is that we cannot see that this is Bayswater, that this is a coal power plant. So that's where the reference data comes in. But essentially, this is the dispatch data we're looking at, for example. Similarly, if I go to another one, this is called dispatch IS, which is the file that they give for price. So if I refresh that again, yeah, this is pretty consistent, which is really good. It's at every 5 minutes, because I think they may delay a bit with the SCADA data, which has, it's like in odd 5-minute intervals. But price, they're very accurate with price. It's every 5 minutes. Companies are being charged and paying on that price. So if I open this file, it is a bit of a mess. I think it is a bit of a mess. We have a few things, and it's kind of messy. We have this one row of data. That's another thing. We have this dispatch local price, which is not what we're after. So there's a mix, and then what we're after here is this block here. So here you can see that we have just the column names here, and then we have the price per state. So New South Wales, the price of electricity, like the wholesale price, was $80, for example. South Australia was 99, which is on the higher side, but Queensland was 79. So it fluctuates. But this is the data that we're going to extract from the dispatch IS file. And similarly, we have another rooftop source in NumWeb. And this is actually only at a 30-minute grain. So because it's, I think because it's not dispatched and you don't, like AMO doesn't pay generators to dispatch rooftop solar, for example, because they're not generated by generators. It's kind of like once it's generated into the grid, then you kind of realize how much sun there is. So we're just going to get this data as a sample. So we're going to open that up and just look at what this data is like. And yeah, so this is very similar. We have just the column names here, and then the actual output. So yeah, New South Wales just in the past 5 minutes on average generated 1,400 megawatt hours, and Tassie, it's not got a lot of sun, so it's only 94. And yeah, New South Wales is very sunny right now, so that's why, right? So we can see like later in the day, we shouldn't expect any rooftop, for example. So we'll see this in a while. So this is the data source that we're working with. And then what we're going to do is we're essentially going to follow this script where we use Databricks for everything. So Databricks is a very, I think maybe like less than 10% have used Databricks or Snowflake, right? So I'll just go through very high level basics. So you have a workspace where it's kind of like a Jupyter notebook if you've used it at uni, for example. And then you can just open you can just open a workspace, which is just folders and files, really. So if I go to the source directory, if I go to the, for example, so this is how I've kind of separated the like the ingestion scripts. So I have a data definition script which just creates the tables that I'm after. So you should expect like a dispatch table, a price table. I've got an integration script which its main responsibility is just get data from that website into our own bucket. And then the processing script which just takes those CSV files and does what we want with it. And then we've got some tests, but I think that's fine. So if I go here and, for example, if I open this notebook, which is create tables, then it's just a notebook. Again, how many of us has used Jupyter Notebook by any chance or similar? So a lot of people, so this might be fairly similar. And, I think it's almost the same. So you can see that, there's just some Python commands that's being run over here. And so you can see that you can print over here is for your own visual testing. So here, for example, I'm running this script called tables silver dispatch SCADA. So what that is it's just the file under tables. And then this is called dispatch SCADA. So for example, this is just and again, like a once-off script, which just kind of creates the table that if it doesn't exist, it's called dispatch SCADA. And then the key thing here about all this is this bit. So this is using Delta with the location, so on and so forth. So what using Delta does is that it tells Databricks that, we're trying to make it a Delta table format. So anything you write onto this table should be a Delta formatted table. And the location, where do we want to store the data? This script itself is a Google Cloud Storage bucket that is just like kind of like a Google Drive, but instead of your personal Google Drive, it's like a cloud storage bucket where you have folders and whatnot. So if I go to Google Cloud Storage, where did I put Google Cloud Storage? Maybe over here. Let me just refresh it. Yeah. So if I go to buckets in my project, so what path did I write here? I wrote this bucket, this folder, this subfolder. So essentially, I go to that bucket, which is this one, and I go to, this was bronze, so I go to bronze. I open bronze up, and you can see the folders that are there. And so dispatch SCADA is just kind of dispatch SCADA. So in this way, I tell Databricks that when I'm creating a table, under the hood, I want it at this location. So what this does is, because it's a Delta format, it's an open source format. So with this data, I don't have to use Databricks to read it. I can use any other tool that can read Delta tables into it. So I've just partitioned it based on the month and year that I'm extracting it from. So for example, you can see here that this is what it looks under the hood. I created a table, but under the hood, I'll just zoom in a bit. And you can see that it's just a snappy Parquet file, and I have no idea how this is configured, but I don't need to, because that's where Delta table comes in. It has a Delta log, which is this one, which manages just the version control. So if I add a new record, if I delete a new record, if I do anything with it, it's managed here, so I don't have to worry about it. I just have to manage it from a control plane perspective. That, oh look, I'm going to store data here, and then any data I write to this table is stored here. That's an example of a Delta table. Databricks also recently open sourced, and I think you can utilize Iceberg tables as well. So that's another open table format that's also open source. So I think I did that for, I think, Rooftop, like this one. Let's see. So let's see this other table, this create table that not exist. This one is using Iceberg here. So that's just another format. So if I go to the same bucket, so this is gold fuel generation by region. If I go to gold fuel generation, so I don't see fuel generation by region. So like a limitation with Iceberg is that I cannot put in the folder I want. It has to, like Databricks, which is this Unity storage, manages it all for me, or makes me manage it all for me. So you can see here that the tables here, you've got this folder, which I didn't write, but on all these subfolders that I did not write, but then because I have this using Iceberg statement, it created an Iceberg format for the data. So yeah, as you can see, /iceberg, metadata, and then this is another format that you can have an open table format, because this is just either JSON files or Parquet files, for example, under the hood, and that's what Google Storage stores, and so it's very cheap. And I think I have over like a few months of data, and it doesn't even cost me $10 a month to store all this Parquet compressed data. And so if I don't use it, I only pay for storage, right? So that's, I think, where kind of Databricks and similar tools kind of really made sense for businesses to scale up if they have a lot of data. And yeah, so like I just create a lot of tables here, and if I want to see the tables, I can go back. I can go to this place called the catalog. So it's just the data catalog. So all of your data assets, similar to SQL Server. They just have a default catalog, so they have a catalog level, and under catalogs you have schemas, and under schemas you have tables. So for example, that gold table that we just showed, and gold is again just like a Medallion Architecture name. You could call it like analytical, or you could call it transformed, or it's just a name, right? But it does serve a purpose. So for example, for end business users, you don't want to expose them to like a bronze table because it's usually got messy data, raw data. You only want to expose them to like either silver plus data sets. So it's very like dependent on the company, but it does serve a purpose to have it in different layers. So for example, like another table is fuel generation total. And you can see that it's got a definition. And if I have a sample data, I need to start using a cluster. So it's everything runs on a compute. So Google handles or like a bucket handles the storage price, but then the compute is where Databricks comes in and charges money to use the compute. I'm on a trial, so thank God, but otherwise I would have been fairly expensive. Let's see. So yeah, you can see that here, like this fuel generation total, this is just a normal table that you could see on a SQL Server or even on Excel. It's not really Excel, but you could just view it like this, and you could run SQL queries on it. But under the hood, this gold table, if I go back to gold, the generation total, you can see that under the hood, it is just all these partitioned delta, compressed snappy parquet files. So this is what the data is, but how I and any end user can see it is just like this. So this kind of helps us to scale out again. So yeah, this is how I created the tables. Let's go to the what was the other one? Let's go to the integration layer. So it's similar. It's just, again, Python notebooks. If you've ever run Python locally, you can run almost the same Python script on this, on like a notebook. So an easier way to show this, you can look at it on a workspace view on Databricks. But because I've got it connected to GitHub, so all of this code here that you see is also on GitHub. So I'll just zoom in again. And you can see it's the same code here. So it's the same, it's like Git connected, so you don't have to worry about version control, or like you can manage versions using Git. And you don't even have to write your code or your commands within Databricks. You can just connect, because it's in Git. It's just another file, so you can actually just open it in like a code editor. And for example, here source conf integration. So yeah, so this is integration, and then this is a job ingest. This is just like a Python script. That so this is the same as this. It just makes it in a notebook format, whereas in VS Code you just have these command and magic comments that you can't really view properly, but it's all right. And yeah, so this job ingest, all that it does, if I scroll to the imports, where's the imports? Okay, so it has a few imports. It's probably not the best. It's like, for example, time isn't used, but I use Beautiful Soup, which is a scraping library to extract the data in, and then I just put it in a bucket. So whenever I run job ingest, what I do is I give it a parameter. I say, just run job ingest with dispatch price. So what that does is job ingest kind of reads under configs. It finds the dispatch price config file. This config file itself is just a JSON file. And that JSON file has all the details you need. So it has the URL, it has the file, like naming convention that is for that file. It has additional info like, which row do you expect, how many rows do you expect the file to have? It has everything that you need. So ideally, this config-driven approach, you can just scale out pretty easily to just get more files in the future if you want. So like dispatch price, for example, again, just for context quickly, we're getting this data in. For dispatch SCADA, we're getting this data in. For NEM, for rooftop, we're getting this data in. And so for the config files has that knowledge. So then what we do after that is if I go to the bucket again, if I go to this one. So because we don't want, this is more of a design question, but I wouldn't want it converted to a Delta table directly. What I would want is I'd want a version of the CSV file for myself, just in case I need it in the future, or I don't want to go back to NemWeb to extract it. So what I do here is I just store the raw data as is. So for example, dispatch price, you can see that it's been partitioned a bit, but that's fine. So you can see that, for example, it's been partitioned by day as well, for example. So you can, so this exact file lives in my bucket as well. So that's what the integration does. Yep.
I see you store region tables in Iceberg.
Sorry. Could you repeat that, sorry?
Oh, I saw in your architecture flow, you store the region tables in Iceberg instead of data tables.
Yeah. So that's when you make it into a bronze or silver or gold table, when you make it into a table that I want to query directly. But this one that I showed you was just before. So it's only part of this integration layer where I just store the raw file as is. Does that answer the question?
No, I mean, in your gold layers, you have Iceberg.
This one?
Yes.
Yeah, so this is another Delta table. So fuel gen region, which is, I just put that as an example. So this table, which is this one is iceberg under the hood. So you can see that it's an iceberg, which just means that if I go to that fuel gen region in gold, which is not on a folder, it's somewhere hidden in its own schema design. Correct. So this is iceberg as an example. The other one, this one, is called is Delta. So Delta is primarily used. I use mostly Delta.
why don't you use the data?
Oh, no, this is just an example. So I just wanted to show that Iceberg can be done on Databricks. I think Delta is more than enough. I think, yeah. And you can also have more optimizations using Delta. And you can, you can put it on your own folder in Delta, which I think helps personally just to manage data. Whereas with Iceberg, you couldn't. Yeah? Does that answer the question? Okay, cool. All right. So then what we do is, if I go back to the scripts again, sorry, then after like getting the data into my bucket, then what I want to do is I want to process it, right? So I process the data. So again, I just put it like this. I have a bronze folder with bronze scripts. I have a silver folder with silver scripts. So for example, if I go to the bronze script, it's just a job again, where I just have a few Python functions and all that to process the data from the bucket, like the raw file, into the first layer, which is bronze. So essentially what the script is doing is that it's getting the file from the raw bucket, which is like something like this. It's just getting literally the partition. Oh, wait. It's just getting the raw file like this, and it's reading it and it's writing to the bronze table. So like this dispatch price data, it goes and writes as a Delta table into this folder. So that's all that the bronze is doing. Similarly, what silver is doing is it's doing a few more transformations. So I'll just go through the transformations quickly. If I go to the SQL editor, so you might be familiar with just a normal SQL editor. So for example, if I look at dispatch price, which is a table that we're looking at before, so we've been able to convert that raw XCSV file all messed up into our raw format, which is just kind of like a table format for the Excel, for the CSV, which is a bit messy. You have a lot of things that don't really make a lot of sense. And that's fine because like that's an example of, bronze is a messy layer. You just get and have a raw version of your original data. And then in silver, which is this energy demo dev, which is this catalog, the silver schema, which is this, and then this dispatch price data. So if I read this, for example, I can see that that file that we had before, which is this one, has been cleaned up. And then it's just kind of a nicer table with only the information that we're after. So you can see that we've got the price, we've got the states, we've got the settlement date times. So that's, that's just an example of how you can have different layers of data, and the more higher you go, the more cleaner it is, ideally. And then similarly, then, for example, that how we get from bronze to silver is using another notebook. So similarly, we have a processing bronze silver notebook. Where is the silver folder? Processing bronze configs. Gold, silver. So yeah, this is just one Python script that just does all the ingestion from bronze to silver for us. And again, this is also config driven. So in a way, when I run this Python script and give it a parameter, call it dispatch price, for example, it reads this JSON file, and then this has all the information that you need to know that, with this bronze table, I want to convert it to this kind of silver table. So similarly, you have another JSON file for SCADA, which tells it, this is stored in this folder. This is the schema that we expect, and these are the transformations that I want to do. So it's almost, trying to make it config driven, so you don't have to rewrite a new script for every single data source, because in enterprise, you can have like hundreds of data sources or tables that you're extracting from. And and similarly, then we have gold tables. So gold tables, I think this is where a bit of like the DBT thing comes in. So a lot of the transformations, but I haven't used that framework. I've just kind of simply had a SQL queries that essentially has a transformation on it. So the silver to gold Python script just runs that script. And so with all of this, you're going to be asking, how do I even run this script? Can I just press run? We don't need to, because Databricks has this thing called jobs here. So here you can see that this job is, if I open up this job here, which is data processing for the SCADA data, and you can see that you've got a lot of runs. It's almost like, it's just like if you use a data factory, for example, it's just like summary of all of your runs. So for example, I ran just before this talk, which is 6:24 p.m. So if I run now again, it'll be another run. And then the good thing with Databricks is that if I go to tasks, which is not a dictionary, it's this one. So I can see that, oh, I run the bronze scripts first, then I run the silver. Then after silver is done, I can run gold scripts, and then I can run a check, for example. So this is just like a simple workflow of whenever I run this job, it just runs these notebooks under the hood. Yeah.
Is it similar to a cloud data flow?
Yeah. I mean, it's just an orchestration tool. Instead of having to press run, yeah, you could, yeah.
Because cloud data flow is Google's
Correct. Yeah.
equivalent of Databricks.
Correct. You could say that. I think there's always a few things. So, for example, with this one, if I have to create a new job, I don't want to like go to jobs and pipelines and then create a new job and then have to add a notebook path in, and I have to find the notebook and everything, which is a bit not great for like production. So what Databricks offers is a concept called Databricks Asset Bundles. So it's kind of like Terraform, but to deploy these pipelines. So under the hood, if I go to the Databricks Asset Bundles, which is just a YAML file, it just has just a definition for that job. So for example, for that one that we just saw, which is an AMO setup, I think data processing it was. So you can see that this data processing job, I tell it, oh, this is where you're going to get the data from. This is the schedule for it. So it's like a quartz cron expression. So it's just, every 5 minutes from 8 a.m. to 8 p.m., 8 a.m. to 8 p.m. And then you have just the tasks, right? So bronze processing is the name of a task. And then that under the hood, that is just this job Python script. So similarly, and once this is defined, the next job is a silver one, but it depends on the bronze job, which is this one. So it depends on bronze. So if I just write this, and then if I just deploy it, then that's going to be reflected over here. So as an example, I can see that all of my jobs are paused right now, but I want to activate it, or I want to do any changes. But as an example, I want to run the job. I want to unpause the job. So what I'll do is I'll just say, all right, I just want to, and this is an example, but I say I'll just call it unpaused. And if I run, you should probably plan it or validate it, but I'm just gonna do Databricks bundle deploy, which is just a command to deploy this YAML file onto the workspace. So it's just gonna find the YAML file. It's gonna find all the folders that this is referencing. It's gonna understand, okay, I've got to run this and that and in this schedule, and everything's kind of defined at a code level, which is really nice. And then it's just getting stuck a bit more than I anticipated, but let's see if it's gonna change anything. So yeah, it's deploying resources, it's doing a few deployment steps. And now if I go back to this screen, and if I refresh this, or if I don't, it just changes. So this is an example of how we can change a trigger. You could change anything here. So it's code driven, and with AI nowadays, you can really automate a lot of the, like all these tags, I could just ask AI to write it, for example, based on a rule, so I don't have to manually do it. And yeah, so this is an example of a job. I do that for the SCADA, the price, what was it, like the rooftop data. Any questions at this stage? We'll go to the dashboard in a bit.
Same thing, Airflow is used as well.
Correct. So I think Airflow is just an orchestration tool again. Databricks has it in its own environment. It's got its own benefits to it. The other benefit with this, for example, is that the tables that we created, because it's smart enough to know that, this was the table before, and we used the data from bronze to make it a silver and to a gold. So we can actually go to a gold table, for example. Let's do this fuel generation region total, and we can look at the lineage. And if I just look at the graph, which is a lot easier to see, I can actually see, okay, this gold table is made up of these two silver tables, right? Or it could be any other table. And if I can go all the way back, saying that, okay, this reference table that I haven't shown, but it's a reference table, it's getting directly from this path. And then this silver table, dispatch SCADA, was made out of bronze dispatch SCADA. So it provides that path. And if you want to go lower, it even gives you the raw Parquet file, or like the raw file that this bronze table is getting the data from. So it just provides a nice lineage graph it helps when you have like a lot of different transformations and a lot of tables. I think you can even go to the column level. So if I go here and I can see that fuel type, which is whether solar or wind, for example, where did I get this column from? So it can actually show me that, oh, like I got this fuel type from this label 1 column from this table. So it just has a visual UI to it. I wouldn't say it's like super revolutionary, but it helps to kind of look at it in a nice, clean way.
Is this feature only available in Databricks?
Correct, yeah. So I think it's a Databricks benefit. I mean, it helps, right? Just if you have think about if you have hundreds of tables and it's not only for you, but for a data analyst, you don't know if I want to use the data or not. This view helps. And again, just because this is a Google talk, again, everything's kind of backed here. So this is a storage bucket that's everything is stored here. It's everything sourced from here. If I delete the bucket, all the data is gone, basically. And yeah, so that's like a benefit of having this lineage graph, and a lot of that is because we ran it on Databricks. So I think we're coming towards the dashboards stage. So again, this is a ELT pipeline, basically extracting from the web, which is very raw CSV data that you saw. We have layers to it, so we make it into a table. We make it a bronze, silver, gold table, and then we have data that we can actually work with. Let's actually just quickly go to see a gold table because I haven't shown that to you guys. So a gold table, for example, what does this generation by region look like under the hood? This is the table that we're going to visualize. And what helps is because if you have a format that you're happy to, you can just visualize this directly instead of having the reporting layer join, process, compress everything before it reports. It makes the visualization a lot faster. So ideally, you want like a simple, clean gold table, ideally. And so, for example, this generation by region literally just shows based on the SCADA data that we got, based on the reference table that we had. We have, this is what 5, which is 6 p.m. It's like 7. So because I haven't run the pipeline, you can see that, there's like, solar in Queensland generated, like this was the average generation for that 5-minute block. We have coal that in New South Wales that generated 4,300, 400 megawatt hours for that 5-minute block. So we have a really clean data set that we can just use to simply visualize it. Let me just see if the pipelines run so I can just get the most recent data. I just put it like every 5 minutes, so that's why it might not be up to date. But yeah, under the hood, it just runs every 5 minutes. So ideally, you have a very, roughly an up-to-date data. This is a batch ELT. It's not a streaming one. I think there's a big jump between batch and streaming, but this is the closest I could get to a near real-time batch because it's a very small data set we're working with for the demo. So while this runs, and I hope it runs in the background, we can look at actually visualizing it. Has anyone used Dash by any chance, like a Plotly Dash by any chance? Has anyone ever heard of a Plotly Dash? Yeah, one person, which is not bad. So it's just a Python library. It's like a visualization tool. It's like Matplotlib, but maybe for like a website. So you can use it for a cleaner approach to, for end users to just view data. So what I've done is under the hood, like I have this apps folder, and apps is a Dash app, and you can see that it's just a Python file. So in this Python file, I just import Dash, which is the main library that we're going to use, and it creates an app, like it instantiates an app, and then we have an app server, and then it's just kind of like HTML under the hood. And with this, so after writing this, and you can have different pages, so it's just like different pages under the same app. So we have the home page, we have a generation page, and all these different pages. So under the hood, for example, the heat, let's go to the region page. It's just, again, just Python scripts. It's using Dash. It's using Dash. It's using Plotly, which is Dash is like that Dash is from Plotly. And then we have some, just some code here to kind of visualize our data. Not using, like, for example, a Power BI or Looker. We're just basing it off of code. So which makes it easy to scale up or version control, because I've had, in my experience, reporting with dashboards, I haven't seen a good version control solution for any any visualization tool. So utilizing Dash ensures that we have a version control over reporting. So once we have this, let me, and so I just deployed it. I can deploy it locally, which I will do now. So cd apps and then deploy local. So this just kind of creates like a local host for me. If I just control click this. Oh. So just, local host, and just this, again, just like this is the website essentially, but it's a Dash based website. So if I go to total, so this Dash app under the hood just reads the gold table. So sorry, I'll just go back to the code quickly just to show that. So here, if I look at here, if I go to search of gold, so you can see that, this is just a select statement of that gold table that we just saw. So just a SQL query that I run and I execute under the hood. So I just execute that query under the hood and this just gives me the data. So this is directly from Databricks. And then I can just, show it on the website. So here, if I go to total, and it might take a while to load because maybe sometimes Databricks serverless is a bit slow. So this is a website. And before I go there, what I did was I actually, instead of just deploying it locally, what I did was I just deployed it on an app engine on Google. So instead of having it locally, I can put it on a website. So if I go back to Google and if I go to this app service, where it is that app service? Sorry, app engine. Oh man, just 1 second. It logs me out a bit more often than I liked it to. I appreciate that it's trying to be secure, but yeah, so let me just look up App Engine. So this is just a Google service that is essentially a managed app. I don't pay for the infrastructure. I just deploy the same code that I would have locally, but into an App Engine. So if I go to the settings of this deployed App Engine, you can actually just, it gives you it should give you a URL. I think it's in the dashboard, but let's see. So where's the URL?
Up there.
Oh yeah, sorry. Nice. So yeah, this is just the appspot.com. So it's it's a Google website. So it's just the same thing, right? But instead of localhost, you just have it on Google. What I did to be just a bit fancy was I just custom domained it. So if I go to settings here, I just kind of map that domain, which is if I sell it or if I show it to like someone else, they're gonna think this is a very weird hacky website. So what I did was I just kind of have this domain. So I just kind of mapped it there. And then if I go to the same domain, I can see the same dashboard, but it's better for the end user. So if I go to total again, and it's gonna load in a while. And so yeah, you can see that. Sorry, let's see if I can do this. No, I can't. So yeah, you can see that this data. If I go here, it's at. Can you see? You can't see. It's at 5:10, which is like 6:10, which is actually a bit delayed. I'm gonna have to see why it's a bit delayed. Let me just run the processing jobs just because it's running. So let's see, hopefully it gets updated. But again, this is slightly old, which is okay, but it's still today. It's December 3rd, I hope today. Yeah. So you can see this is just that generation data that we had the dispatch SCADA data. We converted into like the type of generator that it came from. And then we just have the simple chart to show what the NEM is generating. So you can see that right now, we still have like solar across the NEM again. This is across the 4-5 states. So we have solar, which is this one. Hopefully you guys can see this one. So this is solar. This is wind. So wind forms a large part and it's still running. So we still are getting electricity right now. So some of these lights are, being supported by wind energy. We've got a bit of hydro. And this red one is gas. So gas comes in because if you don't have enough solar or wind, a gas can just switch on and off. So that's why gas peakers, as they're called, they're important to the grid. And then all this black stuff is coal. And these are just the existing coal power plants. And then at the bottom, we have these brown, which is just brown coal. It's only in Victoria. They just burn dirt, which is lignite, but it's just what Victoria does. They just burn brown coal. And then here you can see that I've added the battery bit in. So you can see that all this under the zero on the y-axis is just when the battery's charging. And then this is when the battery is dispatching. So it doesn't necessarily mean that how much you charge is how much you dispatch, but batteries form an important part where they act as a buffer. You can see that during the solar periods, which is around noon, there's a lot of sun. So it means electricity is generally cheaper, and so you can charge batteries. And then during the evening, which was yesterday at 6, it got dispatched. So let's go, and then on that one, let's actually just add in rooftop solar, which was that extra data source. So you can see that rooftop solar is quite large, right? And this is a lot of sun from households, and that is contributing to all the supply of electricity in our NEM network. So it makes sense that it's only during the after maybe like 6 a.m. ish or something, and then it's starting somewhere, and then again this is a NEM, so 6 a.m. here is like 7 a.m. in New South Wales, and then it ends during the evening. So yeah, we've got a lot of sun, and you can see that overall, like the question that I asked before was when do we have a lot of demand, for example, or when do we utilize a lot of electricity? You can see that it's actually during the day we have a lot of supply of electricity, but we actually use a lot of electricity. But at evening, we actually do use a bit, but we don't have a lot of rooftop solar. So what this has done is if I remove the rooftop solar, or if I so it's actually pushed all this down, the rooftop solar, and so you still have like an evening peak. And this is often referred to as a duck curve. Maybe you can see the head here. It's like a duck, So it's like a duck curve, and that's like why, like when rooftop solar came in, and Australia is like really big on rooftop solar, it's like really pushing this down, right? Let's do this, but at a state level. So instead of just by fuel type, we go by region, and we only look at the 4 regions for now. We'll leave Tasmania for last, and hope this loads. It is 4 charts, so maybe that's why it's a bit slow. It does say updating at the top. Let's see. Cool. So yeah, this is a scale. It's not scaled. I think the axis is quite all right. Let me see if I can zoom in just a bit. It doesn't really help, but I'll guide you guys through it. So for example, let's see when the data is chill. So this data is 1635 or 1640, which is 640, which is 740, which is just right now. New South Wales has a lot of need of electricity. So does Queensland. Victoria, although it's like 5 million people, 6 million people, it actually doesn't use a lot of electricity. And then South Australia, being South Australia, I think it's quite low on the usage and on the demand side. We can see that in New South Wales, we can see that we're kind of we're losing sunlight. So this yellow thing here is kind of reducing a fair bit. Whereas Queensland, because maybe for some reason they're out of sunlight, so there's no more solar from the grid coming in. So now we're really we're like really being supported by coal right now. So a lot of the electricity that we use is by coal. And sometimes we have electric cars. We think electricity is nice, it's clean, but sometimes we have to ask, where is the electricity coming from? It's not necessarily a bad thing that we're using coal, because again, we are in a transition phase. But it's good to know that we have coal that is supporting our baseload needs. And yeah, so solar and wind, they're kind of variable. Sometimes you have a really windy or like a windy day like this in New South Wales, and sometimes you just don't. So it's very variable. In South Australia is a good example where it's a lot of renewables. It's like a lot of wind, this blue one. And so it's almost like, from a volume perspective, it's like 80%, 70% wind. But when there is no wind and South Australia needs electricity, they don't have coal power plants or anything. What they rely on are gas peakers, these red ones. So they can switch on and off, but they're really expensive to use. That's why, just coming back to when I talked about how the electricity price is set, if gas comes in and they dispatch electricity, they're going to charge a very high price. So let's look at that. Let's look at the price. Yeah, almost done. And then if I look at the price here, so for example, this is a y-axis. It's a bit hard to see, but right now we can see like a bit of price variability. We can see in general that whenever there's sun, like the price is lower, and now it's like around $100 per megawatt hour in the 5-minute block. South Australia, in this case, like yesterday at 6 a.m., it looks like, when it needed energy, it didn't even have wind. It only had batteries and a bit of solar and just a bit of gas to support it. That's why the price spiked up to like $1,000 that megawatt hour. So it's a very interesting mix of how the generation, the transition, the different supply impacts the price for us. And it doesn't directly. I think there's a bit of hedging going on between when it comes from the generators from wholesale to retail and to us consumers. But it is good to see the underlying infrastructure. And to just kind of close it off, I'll just look at Tasmania. because it's a lucky state. I think it's all renewable. They've got not a lot of people, but a lot of hydro and just enough wind. So it's fully renewable. There's no gas. I think they do have a gas as backup, but it's not really used. So like you can see Tasmania is pretty good in that sense. But of course, it's not realistic for like a state like New South Wales, but Tasmania has got it. And you can see the price here is relatively okay. There's no big spikes. Sometimes there might be, but generally there isn't. And yeah, so that's the end of my talk. I think a bit over time maybe, but thank you all. Any questions? All right, we took a few. Yes, we've got one. Mm-hmm. Or is it what? Sorry. This one. Yeah, it can be done in one workflow. I think that's more of maybe like a design question, whether you want like one notebook, one Python script to run multiple Python scripts. Is that the question? Yeah. 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 Correct. So do you mean more for like a parallel run? Yeah, I mean, there's many ways to do it. You could have the same job run twice in different jobs. There are ways to run the same job in the same notebook using like different clusters under the hood. But in my experience, I just kind of, if there's a need to run different things at the different times, it's like same time, I just run them as its own thing. It's better for debugging and long-term scalability, I think. But yeah, I think it's a design question, but you can, yeah. Any other questions? Yeah.
Your booking with the initial schedule.
Hmm.
And the when you set
How?
tight your schedule.
How tight are my schedules? Is it? Yeah. So this is just a demo. So I kind of just ran it like simply every 5 minutes, so 10, 5, 15, and all that. But it's okay if it's.
You can go ahead with the question.
All right. So yeah, it's so you can run it anytime. So I just run it 10 minutes or like a one-off things. But yeah, you can just run it based on your requirement. Yeah, so it's fully flexible. I would say though, if you have like if it runs every 2 minutes and your job takes more than 2 minutes, you gotta decide. You gotta have almost like a streaming pops up type of like a design. But yeah, ideally like these jobs you run it maximum like once an hour. I would say like if it's production. Yeah.
We'll take that question as a last.
Cool.
Yeah.
Easy. All right. Thank you all. Thank you all for your time. It's been a long evening, but appreciate you being here. Thank you.